Yeah, the least common denominator, that LCD. And a lot of times that worked out to be where you just multiplied the denominator to the other side and vice versa. So if you had to crank this out by hand, you would take 2/3 plus 1/2. You'd have to get the common denominator would wind up being 6. You agree? Now, to change the 3 into a 6, you had to multiply it by 2, but that meant you had to multiply the numerator by 2. Notice, again, when I'm multiplying both the top and bottom by the same number, what am I really multiplying it by? 1. I'm multiplying by factors 1. And we talked about this a lot throughout the course so far this year. Rationalizing denominators with square roots, multiply them by conjugates, things of that nature. We've all kind of multiplied out by these ones before. So you wind up with 4, and over here you multiply by 3 over 3, and you had a 3. Now the real tough stuff. 4 plus 3. Bless you. It wasn't the right answer, but it's close. 7/6, yeah. So what happens here when you do this with the weird stuff is the same basic idea. You're going to be factoring through to find a common denominator, multiplying by pairs of 1s and going there. Unless they already have a common denominator. These are the ones that make you smile. 4 over 3x plus 5 over 3x. Do they have a common denominator? Yes. What do you get? You get 9 over 3x, which simplifies to be 3 over x. And why do I have to do that? I can simplify. And notice I can simplify this problem because there's no addition. It's monomial over a monomial. I can factor, or I can divide out by 3's here to simplify it out. Same idea on the other side. When I'm subtracting, the rule still applies. As long as I have the same common denominator, all I have to do is just put the numerators together. So if I look here, I have x plus 3's for my denominator, so that's fine. The new numerator then would be, now, if I look at this one here, I have 2x minus 4 and then x plus 3. Could I simplify my numerator at all? Yes. How? GCF. I can take out a 2. But does that get me anywhere? No. What I'm asking here, guys, is this is the same thing as saying 2 times the quantity x minus 2 over x plus 3. The reason why I asked if I could simplify it any further is sometimes the numerator and denominator might drop out. Does that make sense? Sometimes it'll be like a hidden simplification that you wind up with really something that will drop out. Sometimes the denominator will have a common factor of 0. Just always just take a quick second and look at it. Can I go any further? If you can, try it. Okay? Not so bad with commons. Complex fractions can have will have like fraction divided by fraction or fraction divided by number and things like that. Those are pretty cool. You're not going to like this. That's the same thing. Now let's look at one without. And that's why we're not going to go so crazy involved in a lot of these things. It's a very good process to make sure you guys understand how to factor and how to group. This is like one of the more complex things that we've done so far. So I have 5 over 6x squared plus x over 4x squared minus 12x. Yeah, what I'm going to do here in order to get this common denominator, the easiest way to go about that is to start by factoring everything out that you can. For example, if I start here, we have 5 over 6x squared. Can't do anything with it. Here, I have an x. What can I factor out of here? Of 4x. I'm left with x minus 3. Everybody okay with that? Okay. Yes. See how now, in this fraction alone, that happens? What's my new numerator now for the fraction on the right? 1. So let's rewrite this one more time. So we have 5 over 6x squared plus 1 over 4 times the quantity x minus 3. Now to figure out the common denominators. The number stuff should be easy for us to figure out. What's the least common denominator of a 6 and a 4? Remember what that meant? That meant, what's the smallest number that they both go into? 12. They both go into 12. 24 would work, but then later on you'd have to simplify out. Using least common denominators makes your lives a little bit easier. Does everybody agree that 12 would be the least common denominator for a 6 and a 4? Okay. So when, we'll move this over here so we have a little more space. What I'm going to do is start by creating my new common denominator. In the past, a lot of times you guys like to just multiply all the denominators together. The example we first did with the 2 and the 3, you got a 6, you just multiply them straight together. Here you automatically want to do 24, but we know we can use 12. What do I do with the x squared and the x minus 3? It's exactly what you do. Does everybody see how the x squared and then the x minus 3 are both separate terms, if you will? So what happens here when I get the common denominator, I have an x squared and an x minus 3. Now it's a matter of figuring out what each of the other fractions needs to get this to work. So the fraction on the left, it has a 6x squared. What would I have to multiply that by to turn the 6 into a 12? A 2, and then what else would I have to multiply it by? Very good. In order to turn this 6x squared into the 12x squared x minus 3, it needs to be multiplied by a 2 and the term of x minus 3. So it becomes 5 times 2 times x minus 3. Same thing with the other denominator. This denominator, in order for it to be turned into the 12, what do you have to multiply the 4 by to turn it into 12? 3. I keep my operation between the two, just like we did before. Yes, sir?
Wouldn't it be 3x squared?
Yeah. I have to multiply by 3x squared, so it becomes 3x squared times 4 times x minus 3. It's ugly looking, isn't it?
Why do you have the 4 times x minus 3?
Oh, I don't need the x minus 3. Thank you. I didn't realize I'd look at that. Okay. Yes, sir?
Can you go over the denominator on
Yeah, I don't understand why we need the 4.
Oh, why not the 6?
No, shouldn't it be x squared times 4?
For this one here?
It would just be 3.
No,
The
final denominator. How do you get the
What?
4x squared times x? The 4 behind the 2x squared.
This, were we talking the second one here? Okay. To turn the 4 into a 12, what do you have to multiply it by?
No, not the numerator, the denominator. The 12x squared
Oh.
times x minus 3.
What's the least common denominator? What's the least the multiple of 6 and a 4? 12. So that's the smallest number that those two both go into. That's where I get this. The x squared and the x minus 3 are just other terms. Just write it down. Why? That's how that's how you wind up getting your common denominators. If you look back at a 2 and the 3, the least common multiple was 6. Okay. If I tack this on with a 2x, the 2 and the 3 would be a 6, but the other term that's still there would be the x. Those other parts, after you factor them out, are the other terms that are with it. They have to continue along the way. What you're doing is you're factoring out If you want to think of it in terms of kind of like prime factorization, and it's kind of a generic way of thinking of it, you're breaking things down into the most simplistic thing that you have left. You're factored stuff out to things that you cannot move. It's all straight multiplication. You just take each chunk shared with each other to become a common denominator. So what does this one have? It has an x squared. It's got to come along. What does this one have? It's an x minus 3. It's got to come along. Now the common denominator shares both parts. The smallest value of the numerical, as well as the terms that each other had. Does that make more sense?
Yeah.
We do a couple of these, and you'll see how this thing flows through. We left off with, we needed a 3x squared. Because I had, well, I shouldn't have. No, I shouldn't have. I don't know why I threw that there. I apologize.
So there's just 3x squared, that's all you put?
Yeah, sorry.
I didn't notice it
There's no 4.
I hate this eraser thing. All right. Again, in order to turn the 4 into a 12, we just had to multiply it by a 3. The original numerator was a 1. I must have looked at it upside down. So. From here, then, all I have to do is just try to see if I can combine anything.
Oh, no, there's an addition sign.
Yeah, there's an addition sign here, so we have what, 10x minus 30. Plus 3x. This is 10 into here. Where does it cancel? It's an addition sign. Yeah. I can't cancel that 2 and the 12 out because of the addition sign in the numerator. Alright. But from here, is there anything else that I can really do? Why bother?
Then you could possibly
Yeah, I guess you could. You can look at it, but I don't think it. Yeah, I don't believe it does. So you need 30 to get to negative, because you have to multiply 30 to get to negative 30. Yeah, not working. So, but yeah, it's ugly, it's complex, but this is about as nasty as this stuff looks. I wanted to throw the worst at you first, and
That's a good, that's a good.
try to go from there. Yes, sir.
Why did you distribute the 10 x minus 30?
To get the a final answer, because you always distribute out your numerator, because you have that addition symbol. That way you can combine like terms, and like we were looking at earlier, sometimes you might find out that all 3 terms or all 4 terms might be even, and then on the denominator, since you're always multiplying stuff together, you might be able to drop something. In this case, there's nothing like that. All right. Let's see what the other one was. This might make you happier. You see why I threw the worst at you first? So when I'm looking at this one, I have 7 over 5x plus 8 over 3x. Right off the bat, what do both denominators have in common? Or even more obvious, what do they both have? X. They both already have a value of x. So I'm going to put x in the denominator. What's the least common denominator of the numbers now? 15. Good. That's where you guys were all going. So the common denominator here between 5x and 3x would be 15x. The reason it is not x squared is because they're not multiplying the x's together. They're already there. They're already terms themselves. 5 times x, 3 times x. So now when I go to the other side, what do I have to multiply the 5 by to turn it into 15? So I multiply top and bottom by 3's. Here I multiply top and bottoms by. Lo and behold, you get 21 plus 40, which gives you 61 over 15x. And I believe 61 is prime. And you're done. Sir?
On the last one, where did you get X minus 3?
It came from the original problem. The original problem had an x minus 3 on the right-hand side. I think it's 4 times x minus 3.
So then why would you put it over?
Because it has to go with everybody. They have to all share parts. I got another one coming up with terms. Here's another one with terms in it. This one, the only thing that's different here is I have subtraction now as opposed to the addition. Again, as you start these things out, they're going to give you things that are non-factored right away. So as you write down the problem, just go ahead and start factoring. That way we can start figuring out what are going to be the common terms that you're going to wind up with. What are going to be the chunks in parentheses that everybody's going to have in common. X plus 1 over x plus 2, x plus 2. Everybody agree with me on that? Over here we have a 2, x plus 2, and an x minus 2. So now, when we start to figure out what your common denominator is going to wind up being, what you always do is write down what do they have in common to start with. In this case here, what do they have in common to start with? X plus 2's. So that each one of them has an x plus 2. Here's a little trick. Since they both have an x plus 2 in common, and I've already written down the common one, oops. I'm going to cross off that I wrote down the common. It's already there. I wrote down a common. Since it's common, we cross off one of each of them. What's left? I got ahead of myself. Now, all 3 terms are accounted for. They both shared an x plus 2. We wrote it down. The one on the left had an extra x plus 2. The one on the right had an x minus 2. Now all possible terms are accounted for. When I go back to the original here, my numerator, yeah,
If you're subtracting, why are they multiplying?
you still have to get the common denominator. It still didn't matter if you were subtracting 2/3 minus 1/2. You still had to get that common denominator, right? Same idea. It just happens to have values of x's in it.
Could you run over how you got the
Yeah.
bottom 3?
Again, as you look at this,
Wouldn't it end up being
when you start looking at your 2 sets of denominators here, what do they have in common? They all have an x plus 2 in common. Since they have an x plus 2 in common, and I wrote down what they both had in common, I just kind of cross it off, just so I know that I took care of it. Now there's nothing else left that they have in common. That means I have to write all the other stuff down. All the other terms get written down. Now everything's accounted for. Okay, does that make it a little bit clearer? Going over again? So now when I look at the fraction on the left, it has x plus 2, x plus 2. What is it missing?
x minus?
X minus 2. So this side, we have to have an x plus 1 times an x minus 2. No, they cannot, because what is this?
Oh.
And what is the fraction on the right missing? It's missing an x plus 2.
Give more examples.
Can you go over and get the numerator again?
When you're looking at this, this guy has both an x plus 2. He already has one of the x plus 2's and another of the x plus 2's. What is it missing? It's missing an x minus 2. So I take that extra x minus 2 and I multiply it up here. Here it has an x, it already has an x plus 2, oops, to go here. It has the x minus 2 to go here. It was missing the other x plus 2, that's why it had to be multiplied to. If you keep going back to the idea of 2/3 plus 1/2, what is it missing? That's what we're looking at. We're, instead of multiplying it and writing it out in long form, I am multiplying it by x minus 2 over x minus 2. I'm multiplying this one by x plus 2 over x plus 2, without writing it all those huge giant steps out. But you guys can probably just get out and walk away. All right? Yes, sir?
No, no.
The last bit of this one here, do not multiply up your denominators. Leave them in your terms, but please write out your numerators because a lot of times you'll be able to combine like terms. Okay? Shouldn't be able to factor anything, but you'll at least be able to combine like terms. So if I multiply out x plus 1, x minus 2, I should get, was that x squared minus x minus 2 minus 2x minus 4. Everybody okay with that so far? Just foiling out and distributive property. So my final numerator would be x squared minus 3x minus 6, which you'll notice you can't factor that, all over
Couldn't you just say like x plus squared?
Yes.
X plus 2 squared. X minus.
if you want, that's fine. Okay. It's a matter of what does it need for each one of those factors, each one of those terms. Factor your denominators out. Figure out what would be the common string, and what is each individual fraction missing to create it. And one more of those.
Mr. Murphy,
Yes, sir.
let's say after you factored out the common, or the numerators,
Uh-huh.
and then they were able to be factored.
Then you can drop stuff through. A lot of times, if it winds up, if you factor everything out, FOIL everything out, and then you can factor it again, I don't think that happens that often. I really don't think it does. It might, but you probably obviously notice right away, x squared minus 3x minus 6, you can't factor it, so you just kind of stop. But if it happened to be x squared minus 5, maybe you might get lucky with that, but I don't think it does very often at all. I really don't. Once again, notice I hit you with the hard stuff, then I come back with something a little bit easier again. X over x minus 4 minus 6 over x plus 3. Do the denominators have any terms in common? Ah, can I break out that x though? No, I can't. So what is the common term? That's why I said terms. Or chunks, do they have anything in common there? No. They have nothing in common. So that means the common denominator will be x minus 4 and x plus 3.
Couldn't you FOIL that out?
How do you FOIL out x? Well, why would you? I don't FOIL denominators. Don't ever FOIL your denominator. Okay? So fraction on the right, what's it missing? X plus 3. So I keep whatever that numerator was, and I multiply it by an x plus 3. I have subtraction between the two. Make sure you be careful with that. Minus 6, and what is the fraction on the right missing now? What is your last step to do then? FOIL, distribute what you need, and combine all your like terms on your numerator, and just rewrite your denominator the way it is. X squared plus 3x minus 6x plus 24 gives us x squared minus 3x plus 24 all over x minus 4, x plus 3. Again, to get to 24 and 3, see 2, 12, 3, 8, 6, and 4, and I can't factor. And I'm done. You're still doing the same process of the longer drawn out style, but it's just it's a little bit quicker. Ready for some revolt?
Why does no one else ever clap?
Because you're the only person that gets excited about math. So I appreciate your
I'm
enthusiasm.
not excited about math, I just think you deserve some, if we all just clapped at the end. You just said we were done.
No, I didn't. I said now it's time for the fun stuff.
I thought that was my homework.
It's the wambulance. You guys are part of the wambulance. You're whining. You're whining and you're whining about the wambulance.
I'm never thought we
It's the wambulance. You get it? Wah, wah, wah. Yes. No, there's an ambulance just went by. There was. It just drove by.
No, what, you didn't see it?
It was going really fast. There's a wambulance, not an ambulance. An ambulance went by. The wambulance is up here. Really? Anywho. Let me show you how this works. You'll be surprised that this really isn't as awful as it looks. It looks really bad.
You play with numbers and get the answer.
Yes.
Why do you put it on?
Because it's complex. All right. Here's what you do. In the first numerator, do I need to do anything? No. There's nothing up there that has to get common denominators. There's nothing up there that can get factored. It's basically leave it alone. What you do is you look at the second one. In this part here, in order to add those two fractions together, I have to have a common denominator. What would a common denominator be? X times x plus 2. Does everybody agree? So what we do is we just start off right with this. We write it as x and then x plus 2. You could write x plus 2 times x. It doesn't matter. I'm just starting it out like this.
Wait, aren't you adding them? I don't bother you.
We will be adding, we're just working with this part for first. We're just working with this nasty looking denominator here. What does this fraction on the left need in order to create this? An x. So I multiply the numerator by x. So what's 1 times x? X. The fraction on the right needs what? X plus 2. So now, that new fraction we've just created turns out to be 3x plus 2. 4. Math is hard. Do we agree that this new numerator is 3x plus 4? So right now, you have this nasty looking stuff, but it's a vertical representation of division. When you rewrite that horizontally, that's when you can start to multiply by reciprocals. Let me show you what this looks like horizontally. You get 2 over x plus 2 divided by 3x plus 4 over x times x plus 2, which turns into the exact same problem you did yesterday, which is multiplying by a reciprocal. Now, if you recognize that right away and you want to write this out as multiplied by the reciprocal straight from the complex fraction, by all means, go for it. No reason then not to. So we have 2 x plus 2 and can anything simplify? The x plus 2's can go away. And I'm allowed to do this again because it's all multiplication. There's no addition here. It's all multiplication. And my final answer is 2x over 3x plus 4. Those are ugly.
Yeah, that is
You should see some of the ones they have in the book. Some of the ones they have in the book are pretty bad. We figure. You drop the stuff that you gave for a gift. Well, you shouldn't give back stuff. It's not nice. Let me give you some of these to try. I do that. This is 9.5 section.
It's even more now because we have the
How's that?
That is good.
Okay. One of the main reasons why I wanted to give you guys just kind of like a brief overview of this adding and subtracting stuff is because we do need to use a very small part of it when we solve equations with this tomorrow. Alrighty?